Hello, science fans. Have you ever wondered why a ball falls down instead of up? Or how a light bulb glows with the flip of a switch? Maybe you've thought about how a boat floats on water, or how your favorite music travels from a speaker to your ears. These are all fantastic questions, and they all have something in common. The answer to all of them, and so many more, is physics. It might sound like a big, scary word from a textbook, but I promise you it's not. Physics is simply the science of how everything in the universe works. From the tiniest particles you can't even see to the biggest stars in the galaxy, it's the ultimate rulebook for reality. Think of physics as the ultimate how-to guide for the world around us. It's not just for scientists in white lab coats mixing potions, it's for everyone. It's for the skateboarder who leans into a turn, the chef who boils water for pasta, and the musician who strums a guitar. All of these activities are pure physics in action. We are all physicists in our daily lives, whether we know it or not. Understanding a little bit about physics can make you see the world in a whole new, exciting way. It turns everyday occurrences into mini science experiments and makes you appreciate the incredible dance of forces and energy happening all around you, all the time. In this guide, we are going to take a journey together into the amazing world of physics. We won't be using complicated math or confusing language. Instead, we'll use simple words and everyday examples to explore the fundamental ideas that govern our universe. We'll look at why things move, what energy is, how electricity works, and so much more. My goal is to show you that physics is not only understandable, but also incredibly cool. It's a story of discovery, curiosity, and our quest to understand the cosmos and our place within it. So get ready to put on your thinking caps and let's get started on this adventure. Our world is full of wonders, from the colors of a rainbow to the pull of a magnet. Each of these phenomena holds a secret, a scientific principle waiting to be understood. By learning about physics, you get the key to unlock these secrets. It's like being given a special pair of glasses that let you see the hidden rules that make everything happen. This journey will empower you, make you more curious, and maybe even inspire you to ask your own questions about the world. And asking questions is what science is all about. So let's dive in and explore the incredible science that makes our world tick. Consider the following: science rules. So what exactly is this thing we call physics? At its heart, physics is the study of matter, energy, and how they interact with each other. That's it. Matter is all the stuff in the universe. Your body, the chair you're sitting on, the air you breathe, and the distant stars. Energy is the power that makes things happen. It's the ability to do work, to create change, to make things move, get hot, or light up. Physics tries to find the basic rules that explain how all this matter and energy behave, from the smallest atom to the largest galaxy. It's the most fundamental of all the sciences. Why is physics so important? Well, because it explains everything. Chemistry is based on the physics of atoms and molecules. Biology is based on the physics and chemistry of living cells. Geology is based on the physics of our planet. Physics provides the foundation upon which all other natural sciences are built. When we understand the principles of physics, we can understand why the sky is blue, why we stick to the ground, and how the sun produces the heat and light that make life on Earth possible. It's the ultimate quest to answer the biggest questions. Where did everything come from? What is it made of? And where is it all going? Think about building with blocks. You have different types of blocks, matter, and you have the energy to stack them, move them, and build things, energy. Physics gives you the instruction manual for those blocks. It tells you that if you stack them too high without a wide base, they will fall over because of gravity. It tells you that if you push a block, it will slide across the floor because of forces. Physics is the set of rules that you have to follow to build anything, whether it's a tower of blocks or a modern skyscraper. It's the science of cause and effect on the grandest scale. The amazing thing is that these rules are the same everywhere. The law of gravity that makes an apple fall from a tree on Earth is the same law that keeps the moon orbiting our planet and our planet orbiting the sun. Isn't that incredible? A few simple, elegant laws govern the entire universe. By studying physics, we are learning the language of the cosmos. It helps us predict how things will behave, which allows us to build incredible technologies, from smartphones to spaceships. It's a powerful tool for understanding and shaping our world, and it all starts with curiosity. Let's start with something we see every single day: motion. Motion is just a fancy word for things moving around. A car driving down the street, a bird flying in the sky, a ball rolling across the floor, that's all motion. Physics helps us describe this motion very precisely. We can talk about how fast something is going, its speed, and in what direction it's moving, its velocity. But the really interesting question is why things start moving in the first place, or why they stop. The answer to that question is a single word: forces. A force is simply a push or a pull. To make anything move, you have to apply a force to it. If you want to kick a soccer ball, you apply a push with your foot. If you want to open a door, you apply a pull with your hand. The famous scientist Sir Isaac Newton came up with 3 basic laws of motion that explain this perfectly. His first law says that an object will stay still or keep moving at a steady speed and in a straight line unless a force acts on it. This is called inertia. It's why you lurch forward in a car when it suddenly stops. Your body wants to keep moving. Newton's second law connects force, mass, how much stuff is in an object, and acceleration, how quickly the object's speed changes. It basically says that to move a heavier object, you need to push or pull it harder. It's much easier to push a toy car than a real car because the real car has much more mass. It also says that the harder you push something, the faster it will speed up. This is something you already know from experience. If you gently push a swing, it moves a little. If you give it a huge shove, it goes much higher and faster. The third law is famous. For every action, there is an equal and opposite reaction. This means that when you push on something, it pushes back on you with the same amount of force. When you are sitting in a chair, your body is pushing down on the chair because of gravity. At the same time, the chair is pushing up on you with an equal force. That's why you don't fall through it. When a rocket blasts off, it pushes hot gas downwards, the action, and the gas pushes the rocket upwards, the reaction, sending it into space. It's a beautiful, balanced dance of pushes and pulls. If forces are what make things move, then energy is what's needed to create those forces. Energy is the capacity to do work. It's the go power of the universe. You can't see, touch, or hold energy, but you can see what it does. It lights our cities, heats our homes, moves our cars, and even powers our bodies. One of the most important rules in all of physics is that energy cannot be created or destroyed. It can only change from one form to another. This is called the law of conservation of energy. It's a very big deal. Let's look at a few types of energy. There's kinetic energy, which is the energy of motion. A moving car, a flying baseball, and a running person all have kinetic energy. The faster they move and the more mass they have, the more kinetic energy they possess. Then there's potential energy, which is stored energy. A book sitting on a high shelf has gravitational potential energy because if it falls, gravity will convert that stored energy into the energy of motion. A stretched rubber band has elastic potential energy, ready to be released to send a paper wad flying across the room. Energy can change forms in amazing ways. Think about a roller coaster. As a chain pulls the car up the first big hill, it is building up a lot of gravitational potential energy. At the very top, it has the maximum potential energy and very little kinetic energy. As it starts to race down the hill, that stored potential energy is converted into kinetic energy, and the car goes faster and faster. As it goes up the next, smaller hill, some of that kinetic energy is changed back into potential energy. This back and forth transformation of energy is what makes the ride so thrilling. This energy transformation happens everywhere. When you eat food, your body uses chemical energy stored in the food to power your muscles, giving you kinetic energy to move around. A power plant might burn coal, chemical energy, to heat water into steam, thermal energy, which turns a turbine, mechanical energy, which spins a generator to create electrical energy. That electrical energy travels to your house and is converted into light energy in a lamp and sound energy in a television. It's all the same energy, just wearing different hats. Understanding this flow of energy is key to understanding the world. Now let's talk about matter. Matter is all the physical stuff in the universe. It's anything that has mass and takes up space. Your desk, the water in your glass, the air you are breathing, it's all matter. For a long time, we've known that matter usually comes in 3 main forms, or states: solid, liquid, and gas. In a solid, like an ice cube, the tiny particles called atoms are packed tightly together and just vibrate in place. This is why solids have a fixed shape. They are rigid and hold their form. In a liquid, like the water you get when the ice cube melts, the atoms are still close together, but they can slide past one another. This is why a liquid can flow and take the shape of its container. If you pour water from a tall glass into a wide bowl, the water changes its shape to fit the bowl. Its particles are free to move around a bit more than in a solid, but they are still attracted to each other, which is why a puddle of water stays together instead of spreading out forever. This freedom of movement is the key difference between a liquid and a solid. When you boil that water, it turns into a gas called steam. In a gas, the atoms are spread very far apart and are moving around very fast and randomly. They bounce off each other and the walls of their container. This is why a gas will expand to fill any container you put it in, no matter how big. The air in a room is a gas, and it fills every nook and cranny. The difference between these states is all about energy. Adding energy, like heat, makes the atoms move faster and break free, changing a solid to a liquid and a liquid to a gas. But what is this stuff made of? If you could zoom in on any piece of matter, you would find that it's made of incredibly tiny particles called atoms. Here's a fun fact. There are more atoms in a single grain of sand than there are grains of sand on all the beaches on Earth. And even atoms are made of smaller things: protons, neutrons, and electrons. Physics at this tiny subatomic level is called quantum mechanics, and it's where things get really weird and wonderful. But for now, just remember that everything you see and touch is a giant collection of these tiny, buzzing atoms. Have you ever shuffled your feet on a carpet and then gotten a small shock when you touched a doorknob? That little zap is a demonstration of electricity, one of the most powerful and useful forces in nature. Electricity comes from tiny particles in atoms called electrons. These electrons can have a negative charge. Other particles, called protons, have a positive charge. Usually, an object has an equal number of both, so it's neutral. But sometimes, electrons can move from one object to another. When you shuffled your feet, you scraped electrons off the carpet, building up a negative charge on your body. The shock was the electrons jumping to the doorknob. This flow of electrons is what we call an electric current. We have learned how to control this flow to do amazing things. In a wire, billions of electrons are pushed along by a force, like water flowing through a pipe. This is what powers everything from your phone to your refrigerator. We use batteries, which create a chemical reaction to push electrons, or generators, which use magnets to do the pushing. Controlling this flow allows us to turn it on and off with a switch. It is one of the most important technological discoveries in human history, completely changing the way we live. Now, let's talk about magnetism. You've probably played with magnets, feeling that strange, invisible force that can pull them together or push them apart. This force comes from the way electrons are spinning and moving inside the atoms of certain materials, like iron. This movement creates tiny magnetic fields. In a magnet, all these tiny fields line up and point in the same direction, creating one big magnetic field with a north pole and a south pole. Just like with electric charges, opposites attract, north pulls south, and likes repel, north pushes north. Here's where it gets really cool. Electricity and magnetism are actually two sides of the same coin. They are part of a single force called electromagnetism. A moving electric current creates a magnetic field around it. This is how an electromagnet works. You just run electricity through a coil of wire to create a powerful magnet that you can turn on and off. And in the other direction, a moving or changing magnetic field can create an electric current in a wire. This is the principle behind electric generators that produce almost all of our electricity. This deep connection is a beautiful example of the unity of a few simple rules in physics. Light is something we experience every moment of our waking lives, but what is it? Physics tells us that light is a form of energy called electromagnetic radiation. That sounds complicated, but it just means that light is a wave made of vibrating electric and magnetic fields traveling through space. It's a part of the same family as radio waves, microwaves, like in your oven, and X-rays. What makes light special is that it's the one part of this family that our eyes can see. Light travels incredibly fast. It's the fastest thing in the entire universe. In 1 second, a beam of light can travel around the Earth more than 7 times. One of the most beautiful things about light is color. The white light that comes from the sun or a light bulb is actually a mixture of all the colors of the rainbow. We can see this when light passes through a prism, which splits the light into its different colors: red, orange, yellow, green, blue, indigo, and violet. Each color is just a light wave with a slightly different length. Red light has the longest waves we can see, and violet light has the shortest. An object's color depends on which light waves it reflects and which it absorbs. A red apple looks red because it absorbs all the other colors and reflects the red light back to your eyes. Light travels in straight lines, which is why you can't see around corners. This property is called rectilinear propagation. It's why shadows are formed. When an object blocks the path of light, it creates a dark area behind it where the light can't reach. We use this property to our advantage with lenses. A lens is a curved piece of glass or plastic that can bend light. A magnifying glass uses a convex lens, thicker in the middle, to bend light rays together to a focal point, making things look bigger. Eyeglasses use specially shaped lenses to bend light to help people see more clearly. But here's a mind-bending fun fact. Sometimes light doesn't act like a wave at all. It can also act like a stream of tiny particles of energy called photons. It's both a wave and a particle at the same time. This is one of the strange and amazing ideas from quantum physics. So, whether it's creating a beautiful sunset, allowing a doctor to see your bones with an X-ray, or carrying the signal for your favorite radio station, the physics of light and the electromagnetic spectrum is a fundamental part of our world, shaping how we see and interact with everything around us. What about the sounds we hear every day? The chirping of a bird, the roar of a car engine, or the sound of a friend's voice? Sound is also a form of energy that travels in waves, but it's very different from light. Sound is a mechanical wave, which means it needs to travel through something, a medium like a solid, a liquid, or a gas. It can't travel through a vacuum, which is empty space. That's why in outer space there is no sound. In movies, when you see a spaceship explode with a loud boom, that's just for dramatic effect. In reality, it would be completely silent. Sound is created when something vibrates, meaning it moves back and forth very quickly. When you speak, your vocal cords vibrate. When you clap your hands, your skin vibrates. This vibration pushes on the air particles right next to it, which then push on the particles next to them, and so on. This creates a chain reaction, a wave of compressions, where particles are squished together, and rarefactions, where they are spread apart, that travels through the air. When this wave reaches your ear, it makes your eardrum vibrate, and your brain interprets this vibration as sound. We can describe sounds in a few ways. The pitch of a sound, whether it's high like a whistle or low like a tuba, depends on how fast the source is vibrating. This is called frequency. Faster vibrations create a higher frequency and a higher pitched sound. The loudness or volume of a sound depends on the size of the vibrations, which is called amplitude. Bigger vibrations push the air particles with more force, creating a more intense wave and a louder sound. This is why shouting is louder than whispering. You are making bigger, more powerful vibrations with your vocal cords. Sound has some neat tricks up its sleeve. You've probably heard an echo before. An echo is simply a sound wave that has bounced off a surface, like a wall or a mountain, and come back to you. This is similar to how light reflects off a mirror. We use this principle in technology like sonar, which is used by ships and submarines. They send out a sound pulse and listen for the echo. By measuring how long it takes for the echo to return, they can figure out how far away an object is, like the ocean floor or another submarine. Physics helps us understand this entire world of vibrations, from music to communication. As we've seen, physics isn't just a subject in a classroom. It is the operating system of our reality. From the moment you wake up, you are interacting with its principles. The alarm clock that wakes you uses the physics of sound or digital electronics. The gravity that pulls you out of bed and keeps your feet on the floor is pure physics. The simple act of making breakfast involves the physics of heat transfer as you toast bread or boil water. The car or bus you take to school or work is a masterpiece of physics, combining the principles of motion, energy conversion in the engine, and electricity in its systems. Think about the technology you use every day. Your smartphone is a pocket-sized physics miracle. It uses the physics of electricity for its battery, the physics of light for its screen, and the physics of electromagnetic waves to send and receive calls and data. The GPS that tells you where to go relies on Einstein's theories of relativity and signals from satellites held in orbit by the laws of gravity. Even entertainment, like watching a movie or playing a video game, is powered by a deep understanding of light, sound, and electricity. We are living in a world built by our understanding of physics. Learning about physics does more than just help us build cool gadgets. It teaches us a way of thinking. It encourages curiosity, logic, and problem solving. When you understand a little bit of physics, you start to see the connections between different things. You see that the same force that makes a baseball curve is related to the force that makes an airplane fly. You learn to ask why and how, and to look for evidence to support your ideas. This kind of critical thinking is valuable in every part of your life, no matter what you do. So, I encourage you to stay curious. Look at the world around you and ask questions. Why does a boat float? How does a microwave heat food? How do sunglasses work? Every question is an invitation to explore the amazing world of physics. You don't need to become a professional physicist to appreciate its beauty and power. By understanding the basics, you gain a deeper appreciation for the elegant, interconnected, and awe-inspiring universe we live in. Physics is everywhere. It is for everyone. And it is, without a doubt, one of the most exciting adventures the human mind can undertake. Go get 'em, science fans!